In this video, we are going to introduce a very famous implementation of a generative character level language model, which in this basically is this GP notebook. This notebook is implemented and written by Peter Novick, which I believe is very famous, one of a very famous person. And this one is actually based on another notebook, or you can see it as a modernized version of this notebook from Goldberg from 2015. And this notebook itself is a response to Andrew Kapas's blog post about also about a character level language model, but using recurrent neural network. So I encourage you to check the original source, original material. They are very interesting reading, and they also provide some code. Although some code from the 2015 are kind of outdated and it would be very difficult to run. However, in our homework, I'll provide some modernized, and this notebook is still very well runnable. The notebook written by Peter Novick, you can still run, and it's very well written. So let's go back to the description. Okay, so before we go into a detail, first of all, I want to mention some source that you can get the training data. Because we are using auto-regressive model and it is a self-supervised model, so it is very kind of easy to get the training source, because all we need is a bunch of raw text. When you got enough raw text as an example, then we can use this example to train a model. The whole idea of an auto-regressive model is that you don't have to do any human labeling. So in fact, you don't need this source. You can actually, if you know how to do the web crawling, or you have some source for downloading any books, articles, then you already have a way to get your training data. However, these repos are some collection of the datasets that are open and can be used to train large language models. Because I think a lot of you are interested in doing training, to do training and fine-tuning for large language models. So it would be a good idea to explore this data that is used to train large language model or to testing large language models. So to get a test or idea what this data is, some of the data are really huge. Like it might require a terabyte storage for some of the one single dataset, and they are typically using a lot of combined different dataset together to train a model. And some are smaller, but still like 50 gigabytes or 100, 200 gigabytes. It is very common to have one dataset that is like 100 gigabytes. So in our homework, in our assignment, you might want just use part of the data, but still you can look into this data and find some of them to play with them. So let's go to the notebook of the character level language model, generative language model. In the notebook, it also uses some data. The data here is the first typical data is the Shakespeare, the writing of Shakespeare's. So you can easily use this command to get this data and to generate to do the experiment to generate something looks like what Shakespeare would write. So here is some small example of what appears in this data file. But again, you can use any kind of data, like in Chinese, in Japanese, or even a programming source code. Or just we probably need a decent amount of data in order to have some accurate estimation of the probabilities. Okay, so here is the code for actually doing to do the estimation of the probability. So basically, it uses a default dict and the counter to do the counting. So the language model itself is just a default dict. So the key of this dict is simply the considered as a Markov chain of order n. So right now we are working with character level. So the key is in fact n character. So we have a very long text. This text contains like maybe 1,000 characters. So the data we are collecting is any consequent, like if we are doing like 5 gram, I'm sorry, the Markov chain of order 5, say 5. Okay. So what we are doing, the key of this dictionary is it's just 5 characters. If it is English, it's just 5 letters, probably including the space or some punctuations or symbols, but just 5 characters. And so this is the key. Then what is the value of this default dict? The value is a counter. It counts the appearance of, suppose we already have these 5 letters, say 1, 2, 3, 4, 5. So the first time we encounter the next letter is the next character is A, and for the second time we have 1, 2, 3, 4, 5 in this text. The next character is B, and the third time it is C. So for each time we do the counting, so we know, okay, so at the end of this loop, we'll know that, okay, we know how many times the 1, 2, 3, 4, 5 has been appeared in this text, and maybe 30 times, or maybe there are 100 appearance of 1, 2, 3, 4, 5 in the whole training data. The training data is just a very long sequence of text, so there may be 100 appearance, maybe 30 of them. The next character is A, and maybe 50 of them. For 50 times of them, the next character is B, and for maybe the rest 20 times of them, the next character is C. So we can do estimation. That is, when we encounter 1, 2, 3, 4, 5, then there are 30% of chance the next character will be A, and the 50% chance the next character will be B, and the 20% chance of the time the next character will be C. So that's it. That's quite simple. It's I will use a different approach that you can see in the video that discussed in the assignment, the homework assignment. But for one thing, I'm also using a default dict and using a counter, because that is quite kind of the modern way of writing this kind of thing in Python. So I'm dealing with this one a little bit differently. I'm using a DQ. That is also a standard Python, like a container or a thing, a collection. It calls collection. So I'm using a DQ because this is actually a DQ. Other than that, what I'm writing, my implementation in the for this homework or for this homework assignment or for this career level generation things are pretty much the same. So okay, so right now we have a pretty good estimation of say some kind of n-gram models. That is, we know some, when we know like when we get the first or any n-1 consequent characters, we have a model to guess how likely the next character would be. So we are going to use it to actually generate the text. So first of all, we are given initial condition, like an initial string. So for the default setting here is we are assuming that we are at the beginning. Then we'll keep getting the last n-1 word. If this is n-gram, we're getting the n-1 not words n-1 characters, and we use this information to check our language model, which is a default dict, and get counting numbers of how likely, I mean at least in the training data, how many times appears, what is the distribution or frequency of the next character would be. Then we use this information, we want to do sampling or to generate the next character. So it has a separate function to do this job. So when we get a counter, this function is by using the information provided. I mean, the information is the frequency of what the next character will be, what the next character is. Then we compute the probability and use this probability to randomly choose the next character. So right now, you can see that it actually do the cumulative probability, and I mean using a random int or something to mimic a distribution that is the same as the frequency, to match the real frequency. So this one is an algorithm that you can actually see that it just do a job. My implementation is using a predefined method that is this kind of work is actually has a name that is called the weighted sampling, because we already know. Suppose we have ABC, and we already know that A 30% we should choose A, 50% we should choose B, and 20% we should choose C. So this one is kind of weighted sampling, because if you use some like a random choice or random sampling without any other argument, just provide a list in it, it will pick each element in equal chance, in equal probability. However, a lot of functions provide some functionality that you can assign different probability of different element. That is this kind of functionality. We usually call it as the weighted sampling. So recently, I think it's maybe like just 2 or 3 years only, that Python standard library provided a function called random dot choices. It provided the functionality doing the weighted sampling. So my implementation is using that function directly. But this one is an implementation pretty simple. Pretty simple, to be fair, to do the sampling that matches the frequency that we already see in the training text. So that's it. We just do the sampling to have a new character and append this character into our text, and using the newly generated text to find the new next one and again, so then we can generate the full text. And also, because we have a language model, we can actually compute several probability, given some sequence, we can predict what is the next one, what is the probability of the next one. For example, if we got a CHAI, and we can ask what is the probability of n after this one. So because of this table, so we know that the frequency, this CHAI appears in this. In fact, there's you don't need to use the sum. There's a total. There's a total. You can simply use LM square brackets and that total, and you can get these things. And this one means the number that encounters of consequent sequence like CHAI, and the next one is n. And this is a number of how many times the CHAI appears in the training text. So by doing this, you got the conditional probability of, given the first 4 letters to be CHAI, what is the probability, at least as we see in the training text, what is the probability of the next character being n. So you can actually do the math and find out the value. It is nearly 70%, and the nearly 30%, the next one would be should be R. So these two characters plus together, we are almost getting something near 100%, because it is 9999. Okay, maybe not exactly the 100%. I'm not sure, but very, very close to 100%. So also you can ask something like S, CHAIS. What is the probability that we have seen in the training text? In this case, we got a 0. That is almost never happened in the training text. So then we use this kind of information, and this function can exploit or utilizing the information stored in the language model to generate the next character that align with the frequency in the training materials. So this one is the actual result of the generated text. So if we we're starting from Romeo, then it will have something like this one. You can see that although this model is very, very simple, extremely simple, this generated text is still very convincing. There may be something weird, like this composites. I'm not sure is it the real word, but this one seems a little bit odd. Maybe you can find a bunch of something that off in this text. Because this one is a sort of old English, so maybe I'm not sure. I mean, THES is a real word, but maybe it is. But for me, this looks at least kind of possible. Because if I just have a really quick glance, I probably wouldn't notice anything wrong about this text, or at least I'm not sure about it. So this one, I mean, if you try to like compliment or saying, okay, the AGI, the ChatGPT is so wonderful because it can generate something looks like Shakespeare's would write. Shakespeare would write. Then you may want to think about it again, because even with this kind of simple algorithm, we can generate something like this one. and with some effort, we might be able to generate something more convincible. So ChatGPT is truly, or the large language model is truly the modern day wonders, for sure. But for probably for some more different reason, for some kind of different reason, not just because it can generate something looks like people would write. We will dig later, and you if eventually we will see what is the differences. So the other example is to generate code. We know that we use Copilot a lot. So one application is we wish to mimic what the large language model will do is to generate code. So by using this simple model and algorithm, we can actually generate things like as complicated as Linux source code. This one is the some example of generated by that simple character level model. Again, if you are not an expert of Linux, at the first glance, it might seem indistinguishable with the real source code. However, if you really think about it, there are some easy to see limitations of this kind of model. First of all, is the quality. The quality is still, if you really look into it, you can see the quality is still behind what ChatGPT has, or other like Llama and or other Mistral or any other or Gma, any other modern models. No matter how small it is, you can still see the difference of the quality. So that is one thing that the modern models better than these simple models. And the other thing is the correctness. That is the most important part, is correctness, because you can see that this one is only has order 10. So if we have we do not have, it is almost impossible to generate a code that has a matching bracket because they are too far away. So when we go here, we probably have to complete have a completion of this the counterpart of this guy, but it is just too far away. It is impossible for this model to remember it even has this guy right here, because it can only remember 10 characters, the last 10 characters. So it is in theory impossible to generate correct code. So that is what we are going to that is something the next model that we are going to introduce would be possible to solve in theory, at least in theory. That is, we can use recurrent neural network instead of simply have a lookup table to count the frequency. The other thing is, the other differences is, if there's something that like some combinations that the model has never seen in the training text, because it is not in the language model. When I say language model, I mean the default dictionary in that we just constructed. It is not a key in the dictionary, so it cannot find the frequency table corresponding to that key. Then we cannot generate anything. However, if we are using a neural network, then because neural network has to output something, so in principle, it has a ability that this simple model does not have. That is, it has a ability to do the generalization. Okay, this one, correctness and generalization, is and also quality also. These are some of the attributes that the larger or more modern or that is superior to this kind of simple models. Okay, so next video will introduce the recurrent neural network that is proposed. This bar plot proposed by Andrew Kapasi.